Welcome my dear students to Standard 10 class Science and Technology Part 1. We continue with Metallurgy. Extraction of aluminium. Aluminium being reactive metal does not occur in nature in free state. Aluminium is the third highly abundant element in the Earth's crust after oxygen and silicon. Aluminium is extracted from its ore, bauxite, Al2O3 and H2O. Bauxite contains 30 to 70% of aluminium oxide, that is Al2O3, and remaining part is gangue, that is impurity. It is made up of sand, that is the impurity is made up of sand, silica, iron oxide, etc. There are two steps in the extraction of aluminium. Concentration of bauxite ore. Bauxite is the main ore of aluminium. Silicon dioxide, that is silica, ferric oxide, that is Fe2O3, and titanium oxide, that is TiO2, are the impurities present in bauxite. Separation of these impurities is done by leaching process using either Bayer's method or Hall's method. In both these methods, finally the concentrated alumina is obtained by calcination. In the Bayer's process, the ore is first ground in a ball mill, that means crushed. Then it is leached by heating with concentrated solution of caustic soda, that is NaOH, that means sodium hydroxide, at 140 to 150 degrees Celsius under high pressure for 2 to 8 hours in a digester. Aluminium oxide being amphoteric in nature, it reacts with aqueous solution of sodium hydroxide to form water-soluble sodium aluminate. This means that bauxite is leached by sodium hydroxide solution. The iron oxide in the gangue, that is impurity, does not dissolve in aqueous solution of sodium hydroxide. It is separated by filtration. However, silica, that is silicon dioxide, in the gangue, that is impurity, dissolves in aqueous sodium hydroxide to form water-soluble sodium silicate. Aqueous sodium aluminate is diluted by putting in water and is cooled to 50 degrees Celsius. This results in the precipitation of aluminium hydroxide. In the Hall's process, the ore is powdered and then leached by heating with aqueous solution of sodium carbonate in the digester to form water-soluble sodium aluminate. Then the insoluble impurities are filtered out. The filtrate is warmed and neutralized by passing carbon dioxide gas through it. This results in the precipitation of aluminium hydroxide. The precipitate of aluminium hydroxide obtained in both Bayer's and Hall's processes is filtered, washed, dried, and then calcinated by heating at 1000 degrees Celsius to obtain alumina. Electrolytic reduction of alumina, that is extraction of aluminium. Look at the diagram over there, my dear children. In this method, electrolysis of molten mixture of alumina, that is Al2O3, melting point greater than 2000 degrees Celsius, is done in a steel tank. The tank has a graphite lining on the inner side. This lining does the work of a cathode. A set of graphite rods dipped in the molten electrolyte works as anode. Cryolite, that is Na3Al F6, and fluorspar, that is CaF F2 are added in the mixture to lower its melting point up to 1000 degrees Celsius. Aluminium is deposited on the cathode on passing electric current. Molten aluminium, being heavier than the electrolyte, is collected at the bottom of the tank. It is taken out from there from time to time. Oxygen gas is liberated at anode. The liberated oxygen reacts with the anodes to form carbon dioxide gas. The anodes have to be changed from time to time as they get oxidized during the electrolysis of alumina. Extraction of moderately reactive metals. The metals in the middle of the reactivity series, such as iron, zinc, lead, copper, are moderately reactive. Usually they occur in the form of their sulfide salts or carbonate. It is easier to obtain metals from their oxides rather than sulfides or carbonates. Therefore, the sulfide ore is strongly heated in air to transform them into oxides. This process is called roasting. Carbonate ores are strongly heated in a limited supply of air to transform them into oxides. This process is called calcination. The following reactions occur during roasting and calcination of zinc, that is ZNS plus O2 giving you ZNO plus sulfur dioxide. In calcination process, combination of calcium, that is zinc, ZnCO3 giving you ZNO plus carbon dioxide gas is liberated. The zinc oxide so obtained is reduced to zinc by using suitable reductant such as carbon. ZNO plus carbon giving you zinc plus carbon monoxide gas is liberated. Apart from carbon, reactive metals such as sodium, calcium, aluminium are also used as reducing agents for the reduction of metal oxides to obtain the metal. This is because these metals displace a moderatively reactive metal from its compound. For example, when manganese dioxide is ignited with aluminium powder, the following reaction takes place. MnO2 plus aluminium giving you Mn plus Al2O3 plus heat. Extraction of less reactive metals. The metals at the bottom of the reactivity series of metals are less reactive. That is why they are found in free state in nature. For example, gold, silver, platinum. The reserves of copper in free state are very few. Presently, copper is found mainly in the form of Cu2S, that means combination of copper and sulfur. Copper is obtained from Cu2S ore just by heating in air. Cu2S plus O2 giving you Cu2O plus sulfur dioxide gas is liberated, and this Cu2O, when it is combined with Cu2S, that is sulfide, gives you copper and sulfur dioxide gas is liberated. In this way, copper is obtained from its sulfide. Extraction of less reactive metals. The metals at the bottom of the reactivity series of metals are less reactive. That is why they are found in free state in nature. For example, gold, silver, platinum. The reserves of copper in free state are very few. Presently, copper is found mainly in the form of Cu2S, that is combination with sulfur. Copper is obtained from Cu2S as just by heating in air. In presence of air, Cu2S plus O2 giving you Cu2O plus sulfur dioxide gas is liberated, and oxygen is separated from copper by reacting with Cu2S giving you Cu plus sulfur dioxide gas is liberated. Refining of metals. Metals obtained by the various reduction processes described above are not very pure. They contain impurities. The impurities need to be separated to obtain pure metal. Electrolysis method is used to obtain pure metals from impure metals. Corrosion of metals. Old iron bars of buildings, copper vessels are not cleaned for a long time. Silver ornaments or idols exposed to air for a long time, old abundant vehicles fit to be thrown away. Rusting of iron articles causes large financial loss. Thus, corrosion of iron, that is rusting, is a big problem. Iron reacts with the moist air and a deposit of reddish substance, that is Fe2O3, water, and a molecule of water is formed on it. This substance is called rust. Carbon dioxide in moist air reacts with the surface of copper vessel. Copper loses its luster due to formation of greenish color of copper carbonate, that is CuCO3, on its surface. This is called patination of copper. On exposure to air, silver articles turn blackish after some time. This is because of the layer of silver sulfide, that is Ag2S, formed by the reaction of silver with hydrogen sulfide in air. By oxidation of aluminium, a thin layer of aluminium oxide is formed. Prevention of corrosion. Various methods are used to protect metals from corrosion. Special attention is paid in almost all the methods so that the iron does not rust. We can lower the rate of the process of rusting of iron. Corrosion of metals can be stopped by keeping metals isolated from a direct contact with air. The prevention of corrosion can be achieved in various ways. Some of these methods are to fix a layer of some substance on the metal surface so that the contact of metal with moisture and oxygen in the air is prevented and no reaction would occur between them. To prevent corrosion of metals by applying a layer of paint, oil, grease or varnish on their surface. For example, corrosion of iron can be prevented by this method. We cannot protect the articles permanently from rusting by painting them. The method of painting is suitable for short time. If there is a scratch on the paint on the surface of the article and if a small surface of the metal comes in contact with air, the process of rusting starts below the layer of the paint. Corrosion can be prevented by putting a layer of non-corrosible metal on a corrosible metal. This is done by many ways. The first method by which the corrosion can be prevented is galvanizing. In this method, a thin layer of zinc is applied to prevent corrosion on iron or steel. For example, shining iron nails, pins, etc. In this method, corrosion of zinc occurs first because zinc is most electropositive than iron. After few rainy seasons, the zinc layer goes away and the inner iron gets exposed. Then iron starts rusting. Tinning. In this method, a layer of molten tin is deposited on the metals. We call this as kalai. A greenish layer forms on the surface of the copper or brass vessel. This greenish layer is poisonous. If buttermilk or curry is placed in such a vessel, it gets spoiled. Tinning is done to prevent all such damages. Third method to prevent corrosion, anodization. In this method, metals like copper, aluminium are coated with a thin and strong layer of their oxide, that is combination of oxygen, by means of electrolysis. For this, the copper or aluminium articles is used as anode. As this oxide layer is strong and uniform all over the surface, it is useful for prevention of the corrosion of the metal. For example, when aluminium is anodized, the thin layer of aluminium oxide is formed. It obstructs the contact of aluminium with oxygen and water. This prevents further oxidation. This protection can be further increased by making the oxide layer thicker during the process of anodization. Electroplating. In this method, a less reactive metal is coated on a more reactive metal by electrolysis. Silver plated spoons, gold plated ornaments are the examples of electroplating. Alloying. Majority of the metallic substances used presently are in the form of alloys. The main intention behind this is to increase the intensity of corrosion of metals. The homogeneous mixture formed by mixing of metal with other metals or non-metals in certain proportion is called an alloy. For example, bronze is an alloy formed from 90% copper and 10% tin. Bronze statues do not get affected by sun and rain. Stainless steel does not get stains with air or water and also does not rust. It is an alloy made from 74% of iron, 18% of chromium and 8% of carbon. In recent times, various types of alloys are used for minting coins. Thank you, my dear children.